Hi everybody, Mr. Wyatt here. I'm back and I'm going to continue where I left off after the last video with number 9 on today's review assignment. Remember, the test is on Wednesday. We will have one more day tomorrow for us to review. Okay, so number 9, we have 26 equals 13y. Now remember, 13y doesn't have an operation symbol in it, but we know in algebra whenever we have a number in front of a variable, multiplication is what's being shown. That's 13 times y equals 26. So to undo that, I have to divide by 13. I'm going to rewrite this. By the way, I could write 13y equals 26. I can just reverse it if I want to, because some of you might feel more comfortable seeing it with the variable on the left-hand side. So you can do that if you want to. You wouldn't need to. I kind of like to. It's up to you though. Anyway, to undo this multiplication that's happening here, the inverse would be to divide. Divide by 13. 13 divided by 13 is 1y. Also, we know multiplying and dividing are going to cancel each other out anyway. So y equals, now since I divided 13, I threw my equation out of balance. I need to divide this other side, the right side of the equal sign, by 13 as well. 26 divided by 13 is 2. Y equals 2. Test it. Does 13 times 2 equal 26? Yep, it does. So y equals 2, which means my answer choice is the first one here, y equals 2. All right, number 10. Now we're getting into some decimals, some rational numbers, but we still handle this the same way. R plus 21.9 equals 27.1. To undo the adding, the inverse operation is subtraction. So I am going to subtract 21.9. Now I'm not going to worry about this yet. Oh, decimals are scary. Just start by showing what you need to do here. We're going to subtract 21.9 here, which will make these undo each other. If you add 21.9, then you subtract 21.9, they undo each other, and we have just R all alone on the left side of the equation equals, but now if I do that there, I have to also do it here, minus 21.9. So to find my answer, I have 27.1. I have to subtract 21.9. So they have to be lined up. We have to line up the decimal points whenever we add or subtract decimals. And my decimal point will come straight down into my answer. But now I cannot subtract 9 from 1 without going in the negatives. So let's make 7. We'll regroup here. Make 7 6. This becomes 11. 11 minus 9 is 2. 6 minus 1 is 5. 2 minus 2 is 0. So R equals 5.2. Is that one of my answer choices? Right here, yes, it is. So I'm going to mark that one. R does equal 5.2. You can always test it when you're done by substituting 5.2 in here. Does 5.2 plus 21.9? Equal 27.1? 9 and 2 is 11. Carry the 1. Decimal point. 5, 6, 7. And then we have the 2 over here. That is what we wanted, 27.1. So I know the answer is correct. All right, number 11, we have 12v equals 19.2. This again means 12 times v. So to undo that, I have to divide by 12. That would be the inverse operation. But if you do that on the left, you'd better do so on the right of the equal sign. 12 divided by 12 is 1v. V equals whatever we get when we divide 19.2 by 12. So let's find out what we get. 19 point foo. How do you like that? All right, 19.2. We're going to divide by 12. Here's my decimal point. 12 will go into 19 once. We get a remainder of 7. Drop the 2 down. Did you notice I brought my decimal point up? Did I mention that? Anyway, I have 72 now, and 12 goes into 72 6 times. 6 times 2 is 12. Carry the 1. 6 times 1 is 6, plus 1 is 7. Yay! I get a remainder of 0. So V equals 1.6. Is that one of my answer choices? Yup-a-doodles. There it is. V equals 1.6. All right, number 12. A plus 3 5/8 equals 7 1/4. Yes, these are mixed numbers. All right, so what I have to do here is subtract. That's how you undo adding, is by subtracting. 3 5/8. I'd better do that over here also. Remember, whatever you do on the left side of the equal sign, you must do on the right side of the equal sign as well. These cancel out. Adding 3 5/8 followed by subtracting 3 5/8. Whoop, whoop, they undo each other. Boy, I'm full of sound effects today, aren't I? Anyway, A is by itself. And it will equal whatever you get when you take 7 1/4 and subtract 3 5/8. To do this, we need a common denominator, which is 8. So 1/4, let's rewrite it so it's over 8 as an equivalent fraction to 1/4. You could multiply these both by 2. 1 times 2 is 2. 4 times 2 is 8. So 7 2/8 minus 3 5/8. I'm going to rewrite that. 7 2/8 minus 3 5/8. I bet a lot of you are viewing this problem right now because this is a pretty tricky one. It's been a while since we've been subtracting mixed numbers. And all of a sudden, how do you subtract 5/8 from 2/8? Well, without going into the negatives, it's just not possible. So we're going to do some regrouping. Let's make 7 into 6. I just took one whole away. How am I going to put that whole back over here in my fractions? Well, that one whole is equivalent to 8/8 if you express it in terms of eighths, which is what we have for a denominator. What's 2/8 plus 8/8? Well, hopefully you would realize that would be 10/8. If you take 2/8 and you add 8 more eighths to it, you'll have 10/8. Now we can subtract. 10 minus 5 is 5 here, and it's out of 8. And then 6 minus 3 is 3. So we find out A equals 3 5/8, which is right here. I think number 12, by the way, is the trickiest problem on the entire assignment. Okay, let's take a look at number 13. N minus 4/8 equals 4 1/4. Okay, so to undo subtraction, I use addition. I have to add 4/8. By the way, is anybody thinking, wait a second, isn't 4/8 1/2? Yes, it is. And you could add 1/2 if you wanted to. But I'm just going to leave it as 4/8 the way it is written here. Subtract 4/8, add 4/8. Those will undo each other. N is by itself. What will N equal? Well, we need to add 4 1/4 plus 4/8. Some of you might be thinking, hey, couldn't I reduce this and rewrite this as 2/4? Then I'd have my common denominator of 4, wouldn't I? Yes, you can. That would be the easiest way to do it. But a lot of you might just be used to the regular way we've been doing these. And so what you can do is take the 1/4 and rewrite it out of 8 by multiplying its numerator and its denominator by 2. So we get 4 2/8 plus 4/8. And so we get 2/8 plus 4/8 is 6/8. And we have the whole number 4 out in front of it. So N equals 4 6/8. Can I simplify 6/8? Well, I could divide them both by 2, couldn't I? And I'd get 3/4. So if N equals 4 3/4 when it's fully simplified. Is that one of my answer choices? Yeah, padoodles. There it is. It's the first one. N equals 4 and 3/4. All right, number 14, we have P divided by 15 equals 8 and 1/3. You know, the left side is pretty easy to see what's going on. We need to undo dividing 15 with multiplying by 15. So I'm going to multiply this side by 15 also. Those undo each other, and P will equal whatever we get when we multiply 8 and 1/3 by 15. Hey, multiplying a mixed number by a whole number? I don't remember how to do that, Mr. Wyatt. Well, that's why I'm here. I'm going to help you out. Go around the horn here. 3 times 8 is 24. 24 plus 1 is 25, and we put that over 3. And we multiply by, and now I can write 15 as an improper fraction by putting it over 1. Any fraction, any whole number can be written as a fraction by putting it over 1. Now, can I simplify anything? I'm sorry, that was kind of loud in the microphone. Yes, 3 divided by 3 is 1. 15 divided by 3 is 5. See, now I just have 1s in my denominator. 1 times 1 is 1. In my numerator, I have 25 times 5. That's like counting quarters. If you had 5 quarters in your pocket, 25, 50, 75, 100, 125, we get 125 over 1, which is just 125. P equals 125. And guess what? That's one of our answer choices. So I'll mark it. P equals 125. And finally, number 15. Tomas buys a bag of 5 peaches for $3.55. Write and solve an equation to find how much money M. Tomas paid for each peach. You know, if you take the number of peaches and multiply by the price per peach, that should equal the total cost, right? Or the total price. Number of peaches times the price per peach equals the total cost. Well, he has 5 peaches times the price per peach. I don't know what the price per peach is. That's what I'm trying to find. The money M Tomas paid for each peach. So it's 5 times M equals the total cost of $3.55. Now, we don't show the times sign in algebra, so I should just write 5M equals 355. Do we have this equation in any of our choices? I see it here. I also see it here. These other ones, no, we're not going to take the M, the cost for each peach, and divide by 5 to get the total cost. That's not right. And we're not going to find the price per peach by taking the total cost. Well, yeah, we are. We are going to do that. So it could be that one. This would also work. You could find the price per peach by taking the total cost and dividing by 5. So this one still is in the running, but I like these two, the way those equations are written. It's going to come down to whether it's 75 cents or whether it's 71 cents. Okay, if it's 75 cents, we're in trouble because both of these would be good then. I hope it's 71 cents. So we have to undo this 5 times M by dividing by 5. It's going to come down to whatever we get when we divide 355 by 5. So 355 divided by 5. Here's my decimal point. 5 goes into 3 0 times. Okay, we're almost done. 5 goes into 35 7 times. 7 times 5 is 35. We get a remainder of 0. But I have one more digit to bring down a 5. 5 goes into 5 once. And we get a remainder of 0. So it is 71 cents per peach, isn't it? Which means our answer choice is this one right here. Okay, 71 cents per peach. And I love peaches. I would have paid 75 cents per peach. I'd be willing because they're that delicious. All right, have a nice day.